For over a decade, Russia marketed the Su-57 as a fifth-generation stealth fighter capable of defeating Western air defenses and maintaining superiority against the F-35. The claims were specific: low radar cross-section comparable to American stealth aircraft, advanced sensor fusion, supercruise capability, electronic warfare systems that could jam enemy radars while remaining undetected. Russia deployed S-300 and S-400 air defense systems to Syria with the explicit claim that these systems could detect and engage stealth aircraft. Syrian operators, trained by Russian advisors, were assured that the integrated air defense network covering Damascus, Homs, and coastal areas would prevent penetration by Israeli aircraft. Between 2018 and 2023, Israeli F-35 Adir fighters conducted over 60 documented strikes inside Syrian territory. Syrian air defense systems never successfully intercepted a single F-35. Not one. The first confirmed F-35I strike occurred in May 2018. The target was an Iranian weapons depot near Damascus International Airport. The facility stored advanced missiles destined for Hezbollah in Lebanon. Israeli intelligence assessed the weapons as precision-guided munitions that could threaten civilian infrastructure. The strike package consisted of 4 F-35I aircraft operating from Nevatim Air Base in southern Israel. Flight time to target was approximately 30 minutes. The ingress route took them through Lebanese airspace, maintaining altitude below 5,000 meters to exploit terrain masking in the anti-Lebanon mountain range. Syrian S-300 PMU-2 batteries were positioned northeast of Damascus, with overlapping coverage zones designed to provide defense against aircraft approaching from Israel. The batteries had been operational for 14 months. Russian advisors had certified the systems as combat-ready. Radar operators were monitoring all approaches. At 2:15 local time, the F-35s released GPS-guided munitions from approximately 40 kilometers range while operating in Lebanese airspace. Time of flight was 90 seconds. The weapons impacted the depot with precision. Secondary explosions confirmed the presence of munitions inside the facility. Syrian air defense reported no radar contacts, and there were no engagement attempts, no missile launches. The weapons depot was destroyed without Syrian operators detecting the aircraft that struck it. 3 weeks later, Israeli F-35 aircraft struck again. The target was a Syrian military research facility near Masyaf, approximately 40 kilometers west of Hama. The facility was assessed as developing precision guidance systems for Syrian ballistic missiles with Iranian technical assistance. This strike occurred in daylight. Weather was clear. S-300 radars were active. Russian advisors were on site at the Air Defense Command Center in Masyaf, monitoring the same facility that was about to be struck. 4 F-35 aircraft approached from the northwest, using the Mediterranean Sea as their ingress corridor. They climbed to release altitude 15 kilometers off the Syrian coast, released standoff weapons, and egressed without entering Syrian airspace. Syrian air defense detected no incoming aircraft. The first indication of an attack was the impact of guided munitions on the research facility. By the time air defense radars were repositioned to scan the likely attack corridor, the F-35 aircraft were already over international waters, outside engagement range. Here is the technical problem. Stealth does not mean invisible, it means delayed detection. An F-35 has a radar cross-section estimated at 0.0015 to 0.005 square meters from the frontal aspect. For comparison, a fourth-generation fighter like an F-16 has a radar cross-section of approximately 1 to 5 square meters. Radar detection range scales with the fourth root of a target's radar cross-section. If an S-300 radar can detect a 1 square meter target at 150 kilometers, it can detect a 0.005 square meter target from approximately 35 to 50 kilometers, depending on the aspect angle, altitude, and atmospheric conditions. From 35 to 50 kilometers is insufficient warning time for effective engagement. At that range, an F-35 traveling at 900 kilometers per hour is 3 to 4 minutes from the weapon release point. If the F-35 is carrying standoff weapons with ranges of 50 to 300 kilometers, it never needs to enter the detection envelope at all. It can release from beyond detection range and egress before Syrian radars acquire a usable track. Even if detection occurs, the engagement timeline is compressed. The S-300 system requires 15 to 25 seconds from initial detection to missile launch under optimal conditions. The operator must confirm the track is hostile, calculate the intercept geometry, receive authorization to fire, and execute the launch sequence. By the time a missile is airborne, the F-35 may already have released weapons and begun evasive maneuvers or electronic warfare countermeasures. Additionally, the F-35 carries the AN/ASQ 239 Barracuda electronic warfare suite. This system provides radar warning, situational awareness, and electronic attack capability. If an S-300 radar begins tracking an F-35, the Barracuda suite detects the radar emissions, analyzes the threat, and can execute jamming to degrade fire control quality or spoof the radar with false targets. Russian advisors in Syria reported multiple instances where S-300 radars detected transient contacts that disappeared before a fire control lock could be established. Syrian operators attributed these to atmospheric interference or commercial aircraft. Intelligence assessments suggest these were F-35 aircraft conducting reconnaissance or deliberately probing Syrian air defense response times. In September 2018, a Russian Il-20 reconnaissance aircraft was shot down by Syrian S-200 missiles during an Israeli strike on Latakia. Syrian operators attempting to engage Israeli F-16 fighters fired multiple missiles. One of those missiles locked onto the Il-20 instead and destroyed it, killing 15 Russian crew members. Tragedy defined the event. Israel was conducting strikes with F-16 fighters that night, not F-35 aircraft. The incident demonstrated that even against fourth-generation aircraft, Syrian air defense coordination was inadequate. Russian anger focused on Israel for creating the situation, but the operational failure was Syrian inability to distinguish between hostile and friendly aircraft under combat conditions. Following this incident, Russia delivered S-300 PMU-2 systems to Syria with assurances that upgraded capabilities would prevent future failures. Russian advisors took direct control of radar operations and fire authorization for several months to ensure proper employment. Israeli F-35 strikes continued. In January 2019, F-35 aircraft struck Iranian positions near Damascus. In July 2019, strikes hit targets near Homs. In November 2019, multiple strikes occurred across western Syria. In each case, Syrian air defense failed to detect, track, or engage the attacking aircraft. Failed detection and tracking was consistent. Russian media reported that S-300 systems were not authorized to fire at Israeli aircraft due to political agreements between Moscow and Jerusalem. This claim was used to explain why the systems never engaged despite being positioned specifically to counter Israeli strikes. However, intelligence assessments and intercepted communications suggest Syrian operators simply could not acquire a reliable track on F-35 aircraft. Radar contacts were fleeting, disappeared before a fire control solution could be calculated, or were lost in ground clutter when aircraft used terrain masking. Fleeting contacts compressed engagement windows and undermined effective response. Compare this to Russian claims about the Su-57. Russia promoted the Su-57 as having a radar cross-section comparable to the F-35. Testing data and analysis by Western intelligence suggest the Su-57 radar cross-section is significantly larger, possibly 0.1 to 0.5 square meters, depending on configuration and aspect angle. This is better than fourth-generation aircraft, but nowhere near F-35 levels. Su-57 also lacks the extensive operational testing and refinement that the F-35 has undergone. The F-35 has been employed in combat by multiple nations. Israel, the United States, and the United Kingdom have all used the F-35 in strike operations. The aircraft has accumulated tens of thousands of flight hours and hundreds of combat sorties, demonstrating operational maturity. Su-57 has no documented combat employment. Russia produced fewer than 15 operational aircraft as of 2023. The program has faced delays, technical problems, and budget constraints. Export customers who initially expressed interest, including India and Turkey, either withdrew or delayed procurement due to concerns about performance and reliability. Syria became the testing ground where Russian air defense systems and stealth fighter claims were operationally evaluated. The evaluation showed that the S-300, despite Russian assurances, cannot effectively engage fifth-generation stealth aircraft. Detection occurs too late, and engagement timelines are too compressed. Electronic warfare capabilities on the F-35 degrade fire control quality. This has strategic implications beyond Syria. Countries that purchased Russian air defense systems based on claims of effectiveness against stealth aircraft now have operational evidence showing those claims were exaggerated. Turkey operates the S-400. China operates S-400 systems and domestic variants. Saudi Arabia considered purchasing the S-400. All of these nations now know that the S-400 struggled to even detect the F-35 in Syrian operations, let alone engage it successfully. The failure is not entirely the fault of the air defense system. Stealth aircraft are designed specifically to exploit radar detection limitations. The physics of radar cross-section reduction create detection range problems that no conventional radar can fully overcome without fundamental changes to wavelength, power, and signal processing. But Russia marketed the S-300 and the S-400 as solutions to the stealth problem. The systems were sold with assurances that they could detect and engage low observable aircraft. Syria provided the operational test. The systems failed. Russia also claimed that the Su-57 would provide stealth capabilities comparable to the F-35. That claim remains unproven. The Su-57 has not been employed in contested airspace against modern air defenses. Until it is, the claim is marketing, not operational reality. Israel conducted over 60 strikes in Syria using the F-35. 0 confirmed losses. 0 confirmed intercepts. Syrian air defense, equipped with Russian systems and advised by Russian personnel, failed to prevent any strike. This is the gap between claimed capability and demonstrated performance. Stealth works not because it makes aircraft invisible, but because it compresses the detection and engagement timeline to the point where effective intercept becomes geometrically and kinematically impossible for conventional air defense systems. Russia trusted that its air defense technology and its stealth fighter program could counter Western fifth-generation aircraft. Syria provided the test environment, and Israeli F-35s provided the operational evaluation. The evaluation showed that trust was misplaced. Russian systems could not detect the F-35 in time to engage. Russian stealth fighter claims remain unvalidated by combat employment. The gap between what was promised and what was delivered is now documented in 60 strike missions where Syrian air defense never fired a shot. Russia trusted stealth fighters and advanced air defense. Israel's F-35 showed that trust was not supported by operational reality.